Have you ever gazed up at the night sky, at that familiar silvery orb we call the moon, and wondered if there was more to its story? We see it as a constant companion, a solitary sentinel in the dark. But what if I told you that wasn't always the case? What if, long ago, Earth wasn't the home of one moon, but two? It sounds like science fiction, but this is a genuine scientific theory that could solve some of the moon's most enduring mysteries. To understand it, we need to travel back in time, way back, about 4.5 billion years ago, to the chaotic early days of our solar system. Back then, the Earth was a very different place. It was a molten, fiery world, still recovering from a cataclysmic event. The leading theory for our moon's formation, known as the giant impact hypothesis, suggests that a Mars-sized planet, which scientists have named Theia, slammed into the young Earth. The collision was so immense it was almost unimaginable. A tremendous amount of molten rock and debris was blasted into orbit around our planet. Over time, gravity did its work, pulling this debris together, clumping and compacting it until it formed the large spherical body we know today as the Moon. But the story might not end there. Some scientists believe that the Theia impact didn't just create one moon, it created two. The main collection of debris formed our large moon, but a smaller secondary collection of material could have coalesced into a second, much smaller moon. Imagine that sight. A night sky with not one, but two celestial companions orbiting our planet. This little brother moon would have been significantly smaller, perhaps only a third of the diameter of the main moon. It would have shared an orbit with its larger sibling, trailing or leading it around the Earth in a stable gravitational dance known as a Trojan point. For millions of years, this cosmic duo would have circled our planet together. So, where did our second moon go? Why do we only see one today? The answer lies in a slow, inevitable cosmic dance that ended in a dramatic collision. Over millions of years, the gravitational interactions between the Earth, the Sun, and the two moons would have slowly destabilized the smaller moon's orbit. It began to drift. It wasn't a sudden event, but a gradual, creeping change in its path, pulling it ever closer to its larger sibling. Then, the inevitable happened. In what must have been one of the most spectacular yet slowest collisions in our solar system's history, the smaller moon finally crashed into the larger one. Because they were in similar orbits, this wasn't a high-speed, explosive impact like an asteroid strike. Instead, it was more like a cosmic splat. The smaller moon, moving at a relatively low speed, essentially pancaked against the surface of the bigger moon, spreading its material across one hemisphere. This big splat theory provides a fascinating and elegant explanation for one of the moon's most puzzling features, its two vastly different faces. Have you ever heard of the dark side of the moon? It's a bit of a misnomer. It's not actually dark, it just always faces away from us due to tidal locking. A better name is the far side, and the far side looks dramatically different from the near side we see every night. The near side, the face we're all familiar with, is relatively smooth and flat. It's covered in vast, dark plains of solidified lava called maria, or seas. These were formed by ancient volcanic activity. But the far side? It's a completely different world. It's rugged, mountainous, and densely cratered, with a crust that is significantly thicker and geologically different. For decades, scientists have wondered why this stark difference, this lunar dichotomy, exists. The two-moon theory offers a compelling answer. The slow-motion collision with the smaller moon would have essentially plastered its rocky material onto one side of the larger moon. This added layer of crust would have made the far side thicker and more mountainous. This extra thickness would have also made it much harder for magma from the moon, as interior, to erupt onto the surface, which explains why the far side has so few maria compared to the near side. The impact essentially gave the moon a second, thicker layer of skin on one half of its body. Think about it. The remnants of that lost second moon could be what makes up the highlands of the lunar far side. We're not just looking at one celestial body. We're seeing the fused remains of two. The collision would have resurfaced an entire hemisphere, creating the rugged, cratered landscape that puzzled astronomers for so long after we first got pictures of it from space probes in the 1960s. This theory helps connect the dots. The giant impact that formed the moon in the first place, the curious two-faced nature of the lunar surface, and the laws of orbital mechanics all come together in this incredible story of a long-lost celestial sibling. Of course, this is still a theory, and scientists are actively researching and debating it. To prove it definitively, we'd need to analyze rock samples from the lunar far side. Future lunar missions, like those planned under the Artemis program, could be key. If astronauts or robotic probes could collect samples from the far side's highlands and find that they have a slightly different geological composition or age than the near side, it would be powerful evidence supporting the Big Splat hypothesis. Until then, it remains a tantalizing possibility. It changes the way we look at our closest celestial neighbor. The moon isn't just a static rock in the sky. It's a dynamic world with a violent, complex, and fascinating past. It's a cosmic crime scene, holding the clues to a sibling rivalry that ended in a planetary-scale merger. So, the next time you look up at that beautiful shining moon, take a moment to consider its hidden history. Remember that you might not be looking at just one moon, but the ghost of two worlds combined into one. You're seeing the survivor of a cosmic collision that shaped the face of the sky we know today. What other secrets is the universe waiting to reveal? Thanks so much for joining me on this cosmic journey. If you found this as mind-blowing as I do, be sure to hit that like button and subscribe for more deep dives into the mysteries of our universe. Let me know in the comments what you think. Did we once have a second moon? I'd love to hear your thoughts. Until next time, keep looking up.